Ever wondered how your phone can transform a shaky video into a detailed 3D model of a room? Or how self-driving cars see the world in 3D without expensive sensors? The answer lies in a groundbreaking field called 3D scene reconstruction, and recent breakthroughs are rewriting the rules of what's possible. Let's dive in. At its core, 3D reconstruction is about creating digital twins of the real world. You start with 2D images, like a smartphone video, and use math to calculate where every point in space exists. But here's the challenge. Doing this accurately and in real time has long been a technical Everest. That's where cutting-edge research is making waves. Take SLAM3R, for instance. This method uses a single video stream to build a full 3D map as you move. Think of it as giving a robot the ability to navigate a room by just watching a video. How? By combining advanced algorithms with clever tricks to track movement and depth, even when the camera shakes or lighting changes. It's like teaching a machine to see the world through motion and context, not just static images. Then there's Scaffold-GS, which leverages 3D Gaussians, digital clouds that adapt to your viewpoint. Imagine a video game that dynamically adjusts details based on where you're looking, optimizing performance without sacrificing realism. These Gaussians allow computers to render complex scenes with fewer resources, making real-time applications like augmented reality or virtual tourism more accessible. But here's the real breakthrough. Researchers aren't just improving speed, they're making systems smarter. By integrating probabilistic models and adaptive optimization, these tools handle messy, real-world data with surprising resilience. Picture a drone mapping a forest. Instead of getting lost in tangled branches, it dynamically updates its 3D model to account for shifting shadows and obstacles. It's like giving machines a sense of spatial intuition. The results? Stunning. In tests, these methods outperform older techniques by leaps and bounds, creating smoother, more accurate models with less computational power. And the implications? They're vast. From real-time 3D scanning for disaster response to hyper-realistic virtual environments, this tech is unlocking possibilities we've only dreamed of. So what's next? As these techniques evolve, they'll keep pushing boundaries. Whether you're a tech enthusiast or just curious about the future, one thing is clear. The way we interact with digital worlds is about to get a whole lot more three-dimensional. But here's another question. How do we ensure these powerful tools are used responsibly? Let's shift gears. Ever wonder how scientists make sure AI doesn't accidentally do something harmful? The answer lies in ethical frameworks and transparency, principles that are just as critical as the technology itself. The research we're looking at didn't use large language models like ChatGPT or Bard, so the paper just says nah. But here's the catch. If they had used these tools, the researchers would have needed to explain exactly how. Why? Because AI isn't magic. It's built by people, and that means it can inherit biases, mistakes, or blind spots. Think of it like a recipe. If you don't list all the ingredients, you might end up with a dish that's dangerous or just weird. This isn't just about being careful. It's about building technology that's not just powerful but trustworthy. Ethical guidelines aren't some boring rulebook. They're the invisible shields that keep innovation from going off the rails. Imagine an AI that accidentally favors one group over another, or makes decisions no one understands. Without clear standards, that's not just a problem for scientists, it's a problem for all of us. Whether you're a creator, a student, or just someone who uses apps every day, these choices shape the world. The next time you interact with AI, remember, behind the scenes, someone had to ask, how do we make this fair? How do we make it safe? Because the future of tech isn't just about what we can build, it's about what we should build. Thanks for sticking with me, because understanding these questions is the first step to shaping a smarter, more responsible tech future. Stay curious, and we'll break down more of these ideas next time.